Okay, here we go. And I'll leave the top one up there just so we can compare how this one's a little tiny bit different in terms of an approach, because these now go up by 2. And so it's going to be a little harder to do this question. These ones go down by 2 each time, all the way across the bottom. Well, it turns out that the going up by 2 and going down by 2 is pretty important. To generate this 4 that I did before, basically I had 4 change of my y value. So here's the change of the y's, that was 4. And I actually am comparing that as a fraction to the change of the x values, which was 1. And 4 divided by 1 was 4. So now I've got a change of the y values of down 2. So change of is a little symbol called delta. So I'm going to use that to show change. So change of the y values is down by 2, and the change in the x values each time is up by 2. So my middle column needs to be a negative 1, not a 4x. It needs to be a negative 1x, or just negative x. So let's get some space and we can build that column. So there's my x and my y, and I'll just copy out the data really quickly. And now I'm going to create a middle column with negative 1x. And so I just multiply by negative 1 each time. And this idea up here we're going to take a look at a lot more later in this unit. So if you're not quite sure where I'm getting this from, it's okay. Just we're following some algorithmic patterns right now. We're just generating some things. This will always work if these patterns are there. If you go up by the same amount and down by the same amount between x and y, this idea will always work. So now I've got a general equation of y equals negative x. And now, is there a pattern here? And there is. It goes down by 1 every single time. And so this pattern will describe our table, that table up there, perfectly, and allow us to generate, well, if x is 200, what would y be? Well, just substitute 200 in. Negative 200 minus 1 is y would be negative 201. So it works really nicely for generating more values on these tables. Let's take a look at a real-life example of where we can see this in the city around us. Okay, so a taxi in a city charges, and I'm just making these numbers up, but let's say $3.50 to call the cab. So as soon as you make the call, you owe them some money. And then you have to pay an additional 35 cents for each kilometer that you ride in the taxi. And so a couple questions for you. First of all, let's see if we can write an equation relating the total cost C to how far we drove, to the number of kilometers k that are driven. So the total cost is equal to, well, I make the phone call. This is called a flat rate. So I have to pay that of $3.50, and I have to pay an additional 35 cents. So there's your variable cost, and that variable cost depends on some variable, and in this case it's k, which is the kilometers that you drive. So if you go 0 kilometers, you owe $3.50 just for calling the cab. If you go 1 kilometer in the cab, you owe $3.50 plus 35 cents times 1, which is $3.85. So let's see if we can use this equation and solve this next question. How much does it cost to drive 20 kilometers in this taxi? So the cost is, just copy this question out again, 0.35k, and now you do a substitution, 0.35 plus, so 3.50 plus 0.35 times 20, and you might need a calculator for that. That's cost is $3.50 and an additional $7, so it'll cost $10.50, and since this is a word problem, I should write that out and put the proper units in there as well. There's a third type of question that can get asked in this section, and it looks like this. How far can you go for $20? How far can you ride? So, well, we start with the cost function But now I'm not substituting in for 20 for the kilometers, I'm substituting 20 in for the cost. And now we need to use our algebra skills to solve for k. So first step is subtract 350 from both sides, and that gives me 1650 is equal to 0.35k. And just continuing the work up here, I'm dividing 1650 by the coefficient 0.35 so that I can take 0.35k and also divide it by 0.35, which will leave me just with the value of k, and you get 47.142857, continuing forever. And so when I write a sentence, I don't want to say that I can go exactly 47 kilometers and 143 meters. Don't do that. Just say that you could travel about 47 kilometers.